My name is Daniel. I'll be introducing the three systems for our group. Firstly, our main system, we have Thousand Parsec. Thousand Parsec is a framework for building turn-based space empire video games in the 4X genre. This genre is named after the four main goals of the user: exploration, expansion, exploitation, and extermination. Thousand Parsec has a flexible design that allows for different choices in the client and server implementations. The system mainly consisting of the client, which is the application that the user uses to interact with the game universe, and the server that communicates all the network protocols to those users. The server will host the game state and update it to all its users. Next, we have Godot. Godot is a cross-platform game engine that works on multiple operating systems like Linux, Windows, and Mac OS. Godot is capable of creating both 2D and 3D games, pictured here. And those games can be suitable for the PC, mobile, or web environments. The goal of Godot is to provide an all-encompassing, fully integrated game development system. The range of possible games created with Godot far outweighs those created by our other two systems. Godot's main intention is to be used as a tool for games to be developed, and thus it's a wider scope. Finally, we have OpenAge. OpenAge is a cross-platform real-time strategy game engine that is based on the mechanics of the Age of Empires series. Real-time strategy games are roughly similar to those of the 4X genre, but the key difference being they are real-time. So that is, they are not turn-based. And the game clock will always be running. A game engine is a software framework that contains the necessary libraries and support systems or support programs used by those games. Currently, the main focus of the OpenAge project is to provide a game, like I said, similar to the original Age of Empire games, but while allowing modification and multiplayer gameplay.
The first architectural decision that our team picked is the universe abstraction. The universe abstraction's purpose in 1000 Parsec is to encapsulate everything that occurs within the game space. It is used regularly in game design and regular human navigation. The universe is the map, and it represents the environment where the game takes place. It contains the data for describing and visualizing the state of the game settings. Planets, units, players, etc. can interact and move within the space of the universe. It supports movement of players, objects, and units. It is used to calculate units' position relative to each other. The closest abstraction found in OpenAge is the terrain abstraction. It consists of loads of small tiles grouped into chunks. The terrain abstraction contains two coordinate systems, one for tiles and one for chunks. Finally, the closest abstraction found in Godot was the viewport abstraction, which contains the world 2 and 3D properties. These properties contain the system's physical entities. The viewport source file has 3,871 lines of code. For this reason, our team decided to focus on the less complex World 2D abstraction. The abstraction interacts with the physics server 2D, navigation server 2D, and rendering server.
As discussed in lecture, an advantage of abstractions is the ability to modify the implementation without system users being affected. However, a major quality attribute of Thousand Parsecs is extensibility. Thousand Parsecs objects can be extended in meaningful ways, such as enabling ship collisions. Extensibility is also applied to the universe object. Its properties should be extendable. Therefore, while the universe object would be an otherwise sufficient game surface and top-level container for Thousand Parsecs, it is appointed the role of a middle abstraction. The trade-off for extensibility was a map object whose only major function is getting the universe coordinates. It is the universe that interacts with the game entities. OpenAge, unburdened by the need for extensibility, better uses a container abstraction. OpenAge's terrain abstraction does not just get terrain chunks, it attaches chunks through the attach chunk method and renders chunks through the draw method, like this. Creation and transition of terrain is concentrated to terrain.cpp. Concentrated terrain creation has consequences, the main consequence being OpenAge's terrain is tile-based without a defined tile abstraction. While the tile abstraction does not exist, its coordinate system does. Two coordinate systems may cause confusion. The terrain chunk coordinate system gets the chunk, but it is the tile coordinate system that positions the terrain object. Since versatility is a valued quality attribute for game engines, it does not make sense for Godot to adopt the same container abstraction as the other two systems. Moreover, it does not make sense for the game engine to be restricted to contained entities possessing important properties. Instead, World2D owns those properties, which are assigned through various servers, e.g. the physics server for gravitational properties. World2D is needed for the system to remain maintainable. Without it, individual server queries would occur throughout the codebase. However, there is a trade-off. Every time a programmer modifies code, they may introduce a bug. Every time a programmer modifies code communicating with several servers, they may introduce a bug that causes communication to cease with one or more of those servers. Briefly, of Thousand Parsecs and OpenAge, our team of software architects believe OpenAge better uses the container abstraction. Whereas Thousand Parsec's middle universe abstraction cannot be easily changed, OpenAge's lack of a terrain tile class can be easily resolved in the future. While in the same gaming domain, it is difficult to make comparisons between Godot and the other two systems on the basis of a container abstraction.
The second architectural decision our team picked was the publish-subscribe design pattern in Thousand Parsec. The problem this design pattern addresses is the behavior of classes passing messages to each other. In other words, updating other classes based on a change in one class. In this system, the different classes have to be aware of changes to the server being used. The solution to the problem is implementing the publish-subscribe pattern through the use of a class called advertisers. This class handles the system's publisher. OpenAge also uses the publish-subscribe pattern to solve this problem. In OpenAge, there exists the publisher objects that can post updates to a topic, and the nodes that are interested can subscribe and view it. This allows the system to notify its subroutines that a change has been made. Godot solves this problem by implementing the observer design pattern through the use of signals. Signals can be emitted by a node and are handled by connected nodes. This solves the problem since now indirected nodes will be notified of a change of another node.
Here's a comparison of the three implementations of the publisher-subscriber design pattern. Thousand Parsecs has a simplicity of implementation where there's no real restriction on who can subscribe to the publishers. This lack of restrictions has a negative effect where developers have to keep track of the purpose and scope of the individual publishers and updates. This adds a lot of complexity that makes the project less maintainable since the system can easily become untestable and hard to understand. This implementation is motivated by compatibility since it works with a wide range of classes across the project. For Godot, the implementation is more flexible and powerful since it allows for custom signals. These can be sent from any node and can be received by any node. This is a more structured approach than the Thousand Parsecs, since signals only operate within the context of the node objects. This implementation of the pub-sub design pattern is motivated by the adaptability and extensibility quality attributes, since custom signals allow for a high degree of freedom of what they can be used for. The OpenAge implementation is such that the events that are being published are not taken into effect immediately. They're instead added to a queue of events. This has the effect of making the system less responsive to change, but it streamlines the updating process. This will in theory make the code easier to debug since it acts more deterministically in comparison to events being handled as they come. This decision is centered more on reliability and testability because of the well-structured and straightforward execution. Overall, the Godot implementation is the most useful, but this is expected since Godot is a more general-purpose game engine. The other two implementations work well in the more specialized context of their respective projects. However, the lack of structure in the Thousand Parsecs publisher functionality is a notable disadvantage.